Okay, so we are continuing on from yesterday with just our horizontally launched projectile motion problems. So there is no angle, so there is no initial velocity in the y direction, only in the x. So you have to be comfortable reading through some of the problems and identifying what is given and what's not given. Now, again, this was an introduction, so I have everything kind of labeled for you, but I will kind of slowly talk about how you would pick out what pieces of information you have based on how it's worded in the problem. Since these are horizontally launched projectiles, that means they're launched outward this way, so there is no velocity up or down in the y direction. So we don't need to worry about that. So there's a hint, which means any of the initial velocities given in the problem, I want to say 99%, because I don't want to say 100, but pretty much are always going to wind up being Vx, your horizontal speed velocity. Once you know that at any point it's constant. Again, how we use this triangle, if I'm looking for Vx, I cover it up. And since I cover it up, I have delta x, or your distance, all right, over time. If they ask you to solve for delta x, I cover that up, and it is Vx times time. So delta x, thinking about, guys, a lot of the problems are logical, and you should be able to kind of visualize them or like kind of play them out in your head a little bit, right, even at your table. How far away from? Like if they said, okay, skier jumps off skis off of a ramp, but it is, all right, so like let's say it looked like that, and then the ramp hits a little flat stretch and then he goes off. There is not going to be any initial velocity in the y direction. So that means the Vx that he would have been given, all right, if there's initial velocity, that would be the Vx. And then if they ask, okay, well, how far does that skier land from the base of the ramp? Well, think about it. How far. Like if you were to roll a pencil off your desk or a ball off your desk, and I ask, how far away does it land? If you just kind of use your hand to kind of like, okay, well, how far out does it go? You should then realize you're looking for the horizontal spot. All right, so delta x is in meters, time is in seconds, velocity in meters per second, if it's there. And then if they ask you for something like this, if they ask you for how high an object is or how high up was the object when it fell, if they're asking you for height, then when you're using our equation here for height, dy vertical displacement, because we're using g is -10, if the problem comes out with a negative height, we would just drop that because obviously you can't have a negative height. All right, so let's go. I'm going to show you guys exactly how I want every single thing set up. Whether or not you like it, I don't really care. I want you to do it this exact way. And there is a reason for it. There's a method for this, is to kind of train yourselves to be able to break down these kinds of problems, be able to pick out and read a problem and figure out what information you have or what information is given, what you're looking for, and then go through a plan of attack. So we're going to start off here with number 4. Now, I'm just going to pretend like T isn't there for this second. So again, I've labeled everything. A person standing off a cliff throws a stone with a horizontal speed of, now if Vx wasn't there, it literally says horizontal speed of 15 meters per second. Well, on the front, all right, or your equation sheet, you should have that kind of stuff listed. So Vx is 15 meters per second. And then it hits the ground 47 meters from the base of the cliff. So I had someone in one of my earlier classes said, okay, I have Vx and dy. And I was like, well, okay, but what do they ask you for? How high is the cliff? Remember, height, if you look and pointing, that's like up and down. So You're looking for dy. That means you had to have been given here your displacement, your delta x, your distance. So that is a 47 meters. So how we would get this, if this is an 8-point question, you would get 1 point for writing down the given pieces of information and what you're looking for. So that's your first point that you can get, and it's your first step. Your second step is always going to wind up being, all right, figuring out what equation we need to use in order to solve for our question mark. Okay, well, if you're not sure, dy, that's in the vertical set of equations. They didn't ask me for the vertical velocity, they asked me for the height, dy. So I'm going to use this equation, 1/2 gt squared. Normally, right, our other original equation was vit plus 1/2 gt squared, but since there is no vertical velocity, all right, initially, that would just cancel out anyway, so you're left with just 1/2 gt squared. So I simplified it here on your worksheet. So the equation, I want you to write the equation out before you plug any numbers. This is exactly, again, how I want to see it. How good are you at following directions? Whether, again, you like it or not, don't argue, just take the extra 10 seconds. dy is 1/2 gt squared. Okay. G. I don't see a G in the problem, but you guys should know that in this class, we're using it as a constant value, right? -10. Other classes, right? What's the true value? -9.8 meters per second squared. So if I did this 1/2 of -10 times t squared, can I solve for dy right now? No. Why? Because I'm missing something. I'm missing t. So that means in order to find this final answer, I have to go on a side quest. There are two sets of equations to solve for time. One, if you're given the height, you can do 2 times the height over gravity. We just get rid of the negative sign because you can't have a negative in a square root. And then you can also determine time if you are given delta x and vx. So if I covered up t would equal delta x over vx. So that would be your third point, right? So you first point, write all the given information, question mark. Second step, write the equation for the question mark. Okay, see what information you have. If you can solve for it, awesome. You just go to your numbers. If you can't, you're going to wind up missing pretty much time in all of those. So you're going to have to go off on a little side tangent, a little side quest, find time, and then bring it back. So the next step, since we don't have dy, we can't use the one equation, so you're going to have to use t is equal to delta x over vx. That's your third step and your third point when you write it out like that. Your fourth point, next step, plug in the numbers that you have. We were given a delta x of 47. And given a Vx of 15. Just be careful, guys, that because I wrote it in order like this. I wrote Vx first, then delta x, just because of how it appeared in the problem. But make sure you're putting the right number with the right variable. So that is your fourth point. Your fifth point would be get that answer. So in your calculators, 47 divided by 15, round it to 2 decimals, 3.13 seconds. So if you stopped here, you'd only get 5 out of the 8 points. Why? Because we never solved for what we originally needed. We wanted dy. We couldn't go there because couldn't find time. So now that we calculated time, all right, we bring it back now, y'all. What is 1/2 of negative 10? Anyone?
-5.
Correct. So we can do -5. Now we can do t squared. And it, again, is you only square t. So this 3.13 squared, throw that into parentheses. So again, if you're not sure how to type it in or where the squared button is on these calculators, okay, 3.13, see this little x squared guy? That button, you press that, little square symbol pops up, you click on it. And now I want to take that answer and times it by -5. And you would get a displacement of negative 48 point, if we rounded it only to 2 decimals, 98 meters. But again, just double check to what the question asks. What did they finally ask? They asked for how high is the cliff? Can you have something that is a negative height? No. So just thinking about it logically, remember displacement is how far you are from the start. Well, if this is my cliff and the stone lands down here, well, yeah, it's 48.98 meters below where it started. So when they're asking us for our height, the height is just 48.98, no negative sign. And then box your answer. So here are all of your points and everything that needs to be shown. First point, write the given information and your question mark, what we're looking for. Second step, write down the equation for said question mark. Okay, put any of the numbers you're given into that equation. All right, so G is -10 or 9.8, depending upon whatever you're using. In ours class, -10. And we couldn't finish solving this because we didn't have T. So we had to go on a side quest. All right, that's your third step here. Write down that equation to solve for T. Fourth step, plug in those numbers. Fifth step, get the value for time. Once you do, you bring it back to complete the work over here, which is your sixth point. And then your seventh point will be the correct value from your calculation, and the eighth point, the correct unit. We have basically 3 units that we're using, guys. I'm asking you guys to solve for velocity, meters per second, a distance or a height, both meters, and or a time, which is in seconds. Okay? So this is how I want each of these problems done. And then we're going to just take a little gander here at number 7. At number 7. So I'm just going to scribble out this T thing first, pretend like it's not there. Okay, a 25-pound frozen turkey is launched horizontally out of a helicopter that is hovering 112.5 meters above ground. So if it's above ground, the helicopter's got to be, I don't know how to draw a helicopter. All right, so there's your little helicopter. It's hovering a certain distance above the ground. You're given height. You're given dy, and they told us that is 112.5 meters. And then you heave it out of the helicopter, and it lands. What does it say? 55 meters away. It lands 55 meters away. All right, it travels, or it just says it travels a horizontal distance. So awesome. That is our delta x. They want to know with what speed was this thing heaved out of the helicopter. Again, we are not, in these horizontal motion problems, we're not having any initial velocity in the y direction, up or down. So the velocity that they're asking us to solve for here is our Vx. So this piece right here. Okay, that is first step and your first point that you can score out of the total of 8. Okay, so there's 8 points or 8 marks. You miss one of these, okay, or more than one, you get points deducted. What is your second step? What is your second step? Got to be. Once you know what you're looking for, you want to write the equation for that question mark. Okay, Vx. Vx, what does Vx equal? So if I went to the front, covered up Vx, it is equal to delta x over time. So I'm going to write that equation down. Delta x over time. Okay.
Pardon the interruption. Can I have Gerard Mulligan down for guidance, please?
Yes.
Thank you.
Once you guys have this written down, do we have any of those pieces of information?
Yeah.
We do. Which one?
Top.
Top. We have delta x. So I would then write, okay, well, Vx is equal to 55 divided by, oh, snap, we don't have t. So that means, side quest, so our third step, what equation do we have to use to solve for this t? Well, it can't be this covering up t. It can't be delta x over Vx because we don't know what Vx is. You can't be missing 2 out of the 3 variables in a 3-variable equation. That just doesn't work. So, bing bong, right over here, t is equal to 2 times the height over g, in which case we're just using the number 10. So that would be your third step, to write the equation down to solve for t. 2 dy over 10 square root. Okay, that's your third possible point that you can score. And yet you've not done any math yet. Now what do? Do I have dy? I do. So now we're going to put the numbers in the correct spots. So 2 times 112.5 divided by 10, and you're going to need to square root that. So how to put this into your calculator? So guys, make sure you're following along. You want to do everything that's underneath, all right, the radical sign or the square root sign first. So 2 times 112.5 equals, great. Then divide by 10. Remember, you're not done yet. Why? Because you have to square root. So to do it on this kind of calculator, okay, you're going to hit second. See where you see the x squared? There's the square root symbol. We want that one, not the one with the x square root. We just want the square root. So you have to hit second to get to any of the yellows, and then press that, and you should just see this. I forgot to write down that last number. That's okay, as long as you don't hit any other buttons before this. If you just hit second and this negative sign down here, that is going to give you the answer to your last calculation, completely unrounded. So if it was like 13 decimals long, whatever, it's going to take all of that, which is great. Then you would hit equals. So this is going to leave us with a value of how much? 4.743. If we need to round this to 2 decimals, what is that going to give us? Chop it off at 2 decimals, what would it be? 4.74, 4.75, what would it be?
4.74.
Good, 4.74, right? Because this guy here isn't 5 or above, so we're not going to round it. Okay, so first step, given information, question mark. Second step, write the equation for that question mark. Try and see if you can solve it. If you can, awesome. If not, figure out what variable you don't have. Write down the equation you're going to need to solve for it. Plug in the numbers. And all right, so that would be your fourth point. And then your fifth point would be to get that value. Okay, like they said in the, I think it's the cha-cha slide. Okay, once you find time, bring it back now, y'all. All right, so t would go into this equation. Now we can solve for it. Where do I put this 4.7? Under t, which is going to be underneath this 55. So 4.74. And that will give me a Vx of rounding it to 2 decimals,
11.60
11.60.
meters.
Just meters.
Per second.
Meters per second. Any of the velocities or speeds, pretty much meters per second. Okay, then box it, and let's see. Let's go through all 8 points total. Again, given information, question mark. First step, first point. Second step, write the equation for the question mark. Put in the numbers that you have. Okay, if you can solve for it, awesome. Continue on. If not, well, then you need to find that missing piece. So third step, write the equation that you're going to need to use in order to solve time. There's only 2. Okay, we did the one up here, delta x over Vx, and I showed you this one now. So you write that equation, fourth step and fourth point, put in the math, all right, put in the numbers, do the math for it, and then get that answer. That is your fifth step and point, / bringing it back. Okay, the sixth point, to finally do all the work over here that you need. Seventh point is to get the correct number value, and the eighth point, the correct unit. And there you have, all right, your method in order to solve for these projectile motion problems. So what you guys are going to do now is you guys are going to work on numbers 5 and number 6. And then number 8 is very, very simplistical, guys. It says an object rolls off a table is only in the air for this much time. T is 4.95 seconds. 1 point. All right. They want to know what the speed is when it hits the ground. And I wrote down that I'm looking for Vy. So your next step would be to do what? Write the what equation? Equation for what? The question mark. So the equation for that question mark, you go to the front side so you can see your list of equations. Vy, when there is no initial velocity, because it's dropped or just launched horizontally, it's just g times t. So do we have our numbers? G is negative 10, t is 4.95, and then Vy is equal to negative 49.5 meters per second. So this one is only a 5-point problem. First step, given information and question mark. 2, write the question mark or the equation to solve for the question mark. 3, plug in the information, put the numbers in the spots where they belong. 4, get the correct value, and 5, correct unit. All right, so guys, this needs to be exactly how it's done on your quizzes and or your test. This is how it will be graded. So there's no curveballs. So as you're going through 5 and 6, okay, that is where we need to ask questions if we're not understanding something. All right, that's what I'm here for. If we're not sure, okay. So let's go and complete 5 and 6.